On number 22, they want us to show what I've been talking about. They want us to show how those are the same and what are you really doing with respect to that. I already showed that, but here I'm going to show it a bit better. There's y equal x cubed. I'm going to really exaggerate the graphs a bit. I'm going to say this is 1, and let's say the graph runs I can get that. Oh, come on. Missed it by a mile. Right there. And I don't care about the left, just the right, because we are starting at x equal 1. So there's x equal 1. At 1, I am at 1. And they're saying you're going to move half a unit to the right. Again, I exaggerated things. So if I move half a unit to the right, that is dx, which is delta x. That doesn't change. That's really what you're doing. And what we're trying to do is we're trying to figure out, instead of finding this y value, we're going to use approximation. So instead of actually giving the y value, this is what we're going to do. We're going to draw a tangent line. And you could tell from the tangent how this is going to work. If I moved this much in x, the actual change is this much. That's delta y. What I'm going to report, I'm going to report that. So I am off this right here. That's error. Do you see that my approximation dy is less than? So in this case, my answer is going to be an underestimate of whatever this answer should be. And I'll show you what that means once we figure the values out. So I'm going to move a dx, or a delta x, which is 0.5. The change of y is actually right there. What I'm going to report is the yellow highlight. Well, this is how it works. If I really want to figure out what delta y is, what the actual change is, well, that is actually 1.5 cubed minus 1 cubed. And if I plug this in a calculator, that's 2.375. Basically what I did, there's the 0.1, and there's the 1.5 cubed, right? Whatever that is. And that's 1.5. If I look at what dy is, that is, the derivative of this is 3x squared. And if I use differential equations, I cross multiply, and I'll say dy is 3. X initially was 1. So that the benefit is that I'm using the integer instead of the decimal. Times 0.5. That is 1.5. So look how this works. The actual change in this was 2.375, and I'm giving a 1.5. Did you notice that it's less? The reason those are differing by a big, this is a big difference, because y equal x cubed is growing very rapidly. If a function is not growing that fast, then you'll notice that it's okay to really move away from it by a bit. The fact that x cubed grows very fast, 0.5 is a lot of change. That's really a big difference. So you got to be careful with that. And 24 is the last problem. I have an option of using either or. I'm going to show you. So linear approximation, I'm going to use that. Or you could use differentials. I'll show you both since we have time. So if I want to use linear approximation, I want to use a straight line approximation to approximate this. I'm going to really look at 4 and 1 over 4. So here we're going to say that f of x is actually 1 over x. And we're looking at x equal 4, roughly. And I'll just add the 0.002 at the end. That's not a big deal. Well, if I'm using linear approximation, I'm going to use a straight line. So y minus y1 equals m into x minus x1. There. And I need the slope of the tangent. The derivative is negative 1 over x squared, evaluated at 4. That's negative 1 over 16. There it is. And I'll say L of x is negative 1 over 16x plus 1 over 4 plus 1 over 4 is 1/2. That will approximate this function around x equal 4. So L of 4.002 would be negative 1/16 4.002 plus 1/2. If I decided to use differentials, this is what I'm going to say. I'm going to say we still have 4 1/4. So when I look at 1 over 4.002, that's going to be roughly 1 over 4 plus the change of y going from 4 to 4.002. Well, let's see how that works. I'm going to say this is roughly 1/4 plus 0. I'm sorry, not 0. Plus dy. What's dy? dy is f prime of x dx, which is the derivative is negative 1 over, and isn't that 4 squared times dx? Wouldn't that be negative 1 over 0. Nope. Then decimal is at the top. Luckily, we have time. Negative 0.001 over 8. Right? 16, yeah. So wouldn't that be 1/4 minus 0.001 divided by 8? And to show those, so this is what one of them gives, this is what the other gives. If I plug this in my calculator, if I take this piece, negative 1 divided by 16 times 4.002 plus 0.5. I'm getting right there. And if I check what this equals, if I take my calculator and take 1 divided by 4 minus 0.001 divided by 8. How do you like that? Wait, normally they're not exactly the same. 1/4 minus 0.001 divided by 8. Yeah, hey, they do work. Okay. The reason those work extremely close and your ohms the same, because the difference is really, really, really small. 0.002. If the difference was like 0.1, you would have seen a slight difference in those. Alright, and there's the homework.